Thank you. I'm glad to be here. How many people are excited to be here at the number 7 RubyCon? Excellent. Woo! Before I start my talk, I want to say Marcel talked a lot about beauty. So you might want to know that is a flaming maple-backed guitar made by Breedlove, which I consider to be one of the most beautiful instruments around. So I got lots of other pictures of guitars if you want to see them sometime. I can tell there's going to be a problem right away. This stage is way too small and I pace when I talk. So if I suddenly disappear down there, that's what's happened. And I'm going to have to stand back. Try using that one instead? Okay. And can you hear me now? Is that better? Is that okay? Yeah. Okay, good. It's not quite as loud in my ears. Okay, great. My name's Jim Weirich, if you haven't picked up on that yet. I work for EdgeCase, which is a Rails development company. I've been working with them for about 6 months. Before that, I was pretty involved in the Java world as well, doing Ruby and Java kind of at the same time. So that's kind of my background. We'll talk a little bit about that. But first I want to mention the word advanced here. You might want to think, wow, he's really going to go deep into some really complicated Ruby code here. And that's really not the case. What I want to really talk about is not so much the advanced part, but the Ruby part of it. I have found that language, particularly programming languages, tend to shape and form the way you think. So let me give you a little bit of my background so you understand where I am coming from. The very first programming language I ever learned was Fortran, and that was in my physics class, and we learned enough Fortran to drive some CalComp plotters so we could plot the data from our physics lab experiments. And that was great, and I really loved it, and it turned out I kind of followed the whole computer science thing rather than the physics things after I got out of college. My first few jobs involved Fortran. From there, I did some C programming. I got very involved in Modula 2. Does anybody remember Modula 2? At the time, it was I'm going to say a beautiful language. It had really great concepts, and the things I was worried about at the time was modularity, cohesion, and coupling. And Modula 2, I felt, got a lot of those things exactly right. From that point, then, I started getting involved in object-oriented languages, which took the ideas of coupling and cohesion and modularity even farther. So C++ was my first entry into object-oriented design. From there, I got into Eiffel, and Eiffel taught me about contracts and how to write reliable software. Great language, beautiful in its own way. Beautiful in a very different way than Ruby is, but still a beautiful language in its own right, I think. And then I also involved into Java a lot. Now, alongside of that, the second programming language I ever learned was Lisp. Yes, these are your father's parentheses. And it was quite by accident. You see, I signed up when I discovered, hey, this programming thing is kind of fun. In my junior year in college, I signed up for an introduction to Fortran programming so I could learn Fortran just a little bit better. And I got into class, and the instructor started drawing code on the blackboard. We didn't even have whiteboards back then. This is how old it is, okay? He started writing code on the blackboard. And I noticed something right away. It had way too many parentheses to be Fortran. And I sat in that class for 3 days, totally confused. I had no idea what he was doing, why all those parentheses, because I knew a little bit of Fortran. I knew this wasn't right. And all of a sudden it dawned on me what he was doing with the parentheses and the cons and the recursions and the whole thing. And it turns out this introduction to Fortran course had Daniel Friedman as the instructor. Daniel Friedman, those of you who know Lisp, the author of The Little Lisper, The Little Schemer, and all that, he had just come out with the Little Lisper book at that time, so we were getting a lot of the Little Lisper techniques thrown at us in class. And we learned Lisp for about the first 3/4 of the course, and then we switched over to Fortran. So we did get our introduction to Fortran eventually, but by then I was hooked. So I learned Lisp. After college, I got involved with Forth. Forth was great because it's an interactive language, but it's designed for systems with really small resources. And I didn't have a lot of money just out of college. I didn't have enough money to buy it was either an Apple IIe or Apple II or TRS-80. Those were the big computers back then. I didn't even have enough money for them right out of college. So I bought a little single board computer with 2K of memory on it. And you know what? Forth runs great in 2K of memory. I had an editor, an assembler, a compiler, and enough for my application code, all in 2K of memory, which is really cool. Forth is very interactive, not dynamically typed in any way like Ruby is, but it was interactive in the same way that Ruby, and in the same way that Lisp is in a lot of ways. From there, I kind of graduated up to Tickle command language. Thank you. It's been a while since I've done that. Tickle was also cool in a lot of ways, and finally landed into Perl as my standard language for developing tools to help my programming of C++ and Java. So Perl was kind of my tool language. Java and C++ were kind of my professional languages that I used to get real code done, right? And about that time, I was really looking for an alternative to Perl because I really liked Perl. I really loved the way I could get things done in Perl. But you know what? It was unreadable. And when you grew your Perl code to a certain size, it just didn't scale up to larger problems, in my view. I couldn't handle Perl of a large code base. So I was looking for alternatives. And about that time, Dave Thomas, I think it was in the Extreme Programming mailing list, mentioned about this little language called Ruby. So I grabbed Ruby, downloaded it, compiled it on my machine, and tried it, and in one day I had completely converted over to using Ruby rather than Perl. So that was my introduction. And what was great about Ruby, it was an object-oriented scripting language. And I was already really involved in the whole OO movement and working with that from the C and C++ and the Java world, the Eiffel world. But I want to point out that my OO experience up to that time is entirely what we call static languages. So my view of OO was very much shaped by the languages that I had used to do OO. And I knew a little bit of Smalltalk. I knew enough Smalltalk that I could read Smalltalk code, but I'd never written any of it in anger, so the concepts in Smalltalk really weren't a part of me at that time. Ruby was eye-opening. The things that you could do in Ruby, as opposed to like a static language like Java, was incredible. And I really loved that whole Ruby experience. There's a saying, you can write Fortran code in any language. Perhaps the updated version of that should be you can write Java code in any language. And I think a lot of us, how many people have come to Ruby from Java? There's a lot of us here. I think if Ruby is your first introduction to a dynamic OO language, you're going to bring concepts from Java and C++ that a lot of your concepts are going to be great, and they're going to work. The whole thing about modularity and cohesion and coupling, that's going to come right with you, and that's going to work as well. But there are techniques that you can do in Ruby that are inconceivable in Java code and C++ code. We are going to talk about some of those techniques today. So what I really want to do is, if you are boxed by the language that you're thinking in now, I really want to get you to thinking outside of that box. So, what are you going to expect from this talk? Well, first of all, I have 3 examples of more or less real-life code that I'm going to show you right here. These are examples of libraries that I've written and are using in production. And there's one example of one that's just kind of a cool idea. The reason I've included that one because these examples have to be fun. They have to be interesting, and I have to be excited about talking about that. I will make a confession. I was working on this presentation, and I got to the 3rd example. And I was writing it up, and I was about halfway done with writing up, and I made this discovery. I was bored. I didn't like the example. It was interesting code, but the process of explaining it wasn't very interesting at all to me. So I was trying to decide whether to use that example or switch to something else. I happened to forget to save my presentation file, so 2 days later when I came back to revisit it, the whole set of slides for the third example was gone. So I said, good, that's a sign from God. We're changing that example. So the abstract you might have read in the program is a little bit different than what we're doing here. That's okay. The other thing I want to illustrate are techniques that you're not going to find in your standard Java/C++ type of programming. So these are things that you're not going to really run across. So that's what makes this advanced Ruby talk. Okay, so let's go ahead and move on to the examples. And the first one I want to talk, box number 1 that you want to jump out of, I call this the master of disguise. And this is an example that actually comes from Rake. I'm sure most of you have perhaps heard of Rake. Build tool for Ruby. Thank you. Now, Marcel, I think this is a new piece of code beauty, is the fact that people find it useful. That really gives me a thrill more than anything else, that people find code useful. So thank you for that. This is actually a very small piece of Rake that I want to talk about. And in Rake is all about building things and manipulating lists of files. So we have a special class in Rake that handles the collection of file names and finding files in your project and managing them. That's called the FileList object. You can use it a lot like this, as you see on the screen. You give it a glob, a pattern, and it will act then as an array of those file names. Like an array, almost. There are about 4 differences between FileList and a real array. Number 1, it's initialized by a glob. It is knowledgeable about your file system, so it can find those file names in your system. You can include files, you can exclude files, you can do it by patterns and all kinds of interesting things. So it's very knowledgeable about that. It also has a specialized 2S method, and this is the big reason I wrote a specialized class to handle it, is because if you 2S an array, all the things get in there, they're jammed together without spaces. And I really wanted a list of file names with spaces between each one. So FileList has a specialized 2S. It also has some extra methods that don't exist in a normal array. You can manipulate the extensions of all the file names in a file list. You can manipulate their paths, and you can do other interesting things on file lists that are not available in array. But finally, file lists are lazy. The reason is, if you have a Rake file and you have a bunch of different tasks defined in your Rake file, you might define a whole bunch of file lists up front at the beginning of your Rake file that won't be used, but you're just defining them just in case they might be used by one of the tasks that might be called later. So if you initialize a file list by globbing through your file directories and searching for files, building up these lists of file lists could be quite expensive. So Rake file lists are lazy in that they don't actually go out and look at the file system until the first time you need to use the values in that file list. At that point, we go out, we get the values we need, and we bring them in. So if you define 10, 20 file lists at the beginning of your Rake file, none of them actually do anything time-consuming until you actually start using them. So that's a good feature of file lists, and actually the feature we're going to kind of concentrate on today. Now, my first cut at writing file lists looked a lot like this. I said, well, a file list is an array. And so we'll just inherit from array and get all the array behavior automatically. If you come from a static language like Java or C++, one of the first rules that you learn in class design is do not inherit from concrete classes. That carries a whole bunch of baggage with it. Truth is that in Ruby, there are reasons for not inheriting from concrete classes, but they are entirely different than the reasons that you would find in Java or C++. And we'll get into what these reasons are. So I thought, okay, let's go ahead and inherit from this concrete class, and let's just see what happens. And it actually worked out quite well to begin with. Initialize for file list. Essentially, now this is a simplified version. I've simplified the code for the talk here. The real file list is a little more complicated than this. But we initialize a file list by loading a pattern. We save the pattern. We set a resolved flag to false because we have not yet gone out and gotten the file names that exist on the file system yet. And also we call super. That's just good practice when you inherit from a class and your initializer. Make sure you allow the initializers in your parent classes to run as well. So, lazy loading. Just remember the pattern for use later and set the resolved to false so that you know you haven't resolved your file yet. Then you have to write a resolve method. And it's pretty straightforward. When you call resolve, you want to make sure your array is empty, go through the file system, get all the patterns, and insert them into self, which is an array, and then set resolve to true. So when you're done, your file list now contains all the file names out on your file system, and we're resolved. So the next time you won't have to call resolve, and you check that later. Now, does this work at this point? No, you can tell by the title. I gave that one away, didn't I? We haven't resolved it yet. So when we create a file list and we try to access the first member, because we have not resolved anything yet, that array is empty. So this will fail. What we have to do is actually explicitly resolve the file list first. Ouch! That's painful. I don't want to do that. So the way to fix that is to automatically resolve the file list the first time you need it. So we will take the indexing operation and we will replace arrays version with a version that calls resolve if we haven't been resolved yet. And then invokes the super version of index, which calls the array code that actually returns the indexing. Now, that's okay for indexing. Remember, there's a lot of other array methods that need to be handled as well. So you've got to wash, rinse, repeat this over and over again. Now, if I would strongly recommend at this point investigating a little meta-programming to make this easier, so you define this code in one place, and we'll do that in a little bit. I'm going to leave that as is for right now. Okay. Auto-resolve. Great. Actually worked pretty good. And I was really happy, and a couple versions of Rake work exactly like this. And I had very few problems. Then, all of a sudden, someone's reported a bug. This code works. This is using the plus operator that takes two arrays and concatenates their contents together. Plus is a method on a file list. I resolve the file list. Then I concatenate then I call the super version of that, which concatenates the contents, and the result is a list of everything in the file list plus everything in the array. That's the argument to the plus operator. So that works. But what happens if I change the order? We've got a small problem. Array doesn't know anything about resolving file lists. So in this case, the plus is an operator on a regular array. The regular array takes an argument that's a file list, looks at it, and says, oh, I have an array. And it does, because file list inherits from an array. It is an array. So it says, let's concatenate the contents. Oh, we have no contents, so the result is just the first array. You totally never resolve the contents of file list, which is a bug. That's a problem. What are we going to do about that? Okay. Talk about the whys. And we covered that. Okay. If only, I love that phrase, if only there was a way for an arbitrary object to indicate to the Ruby system, hey, treat me as if I were an array. Wouldn't that be a nice thing to have? Because then I could put that into file list and Ruby would work with that. Excuse me. Can someone get me a drink of water? A cup of water? Thank you. I appreciate that. The technology. Turns out there's a method called toArray, toARY, that is designed to indicate exactly this behavior. It says, I am an object. Thank you. It says, I am an object, and I want to be treated as if I were an array. When Ruby senses you have a toArray method on your class, it will call that method, use the result, and that method should return an array as a result. And then it will use that result in all its operations. So it treats your object as if it were an array. Well, that's fine, except FileList too cleverly mimics the fact that it is an array. In fact, it is an array. When Ruby looks at FileList, it says, oh, you're an array. I don't need to call toArray on you. I'm just going to use your content. So the fact I inherit from array in FileList was what was killing me. So to make the toArray method work, I had to modify FileList to not inherit from array after all. Instead, it's a regular object inheriting from just your base class object. Again, the initialize is much the same, except now we delegate to an actual array object that we contain inside of FileList. The @items item there. We have to change our resolving code so that it used to look like this. We now delegate to items instead of calling super. And now everything is cool. We can take an array and a FileList, and when we concatenate them, Ruby says, oh, look, I've got an object that's not an array. Can you act as an array? FileList will say, yes, I have a toArray method on me. Call that, and we'll be happy. Ruby does that, and we get the result back. So that's cool. Remember this? We need to auto-resolve all of those, so I'm going to go ahead and show you what that will look like. Let's dry out that code. Instead of implementing all those methods all over again, you can do something like this. Create a list of methods you need to auto-resolve and do a little metaprogramming using class eval to define all those. So it becomes actually quite easy to inherit from array, or to not inherit from array, but yet implement all of array's behavior. In fact, you can, instead of explicitly setting up resolve, I'm pointing at my screen. Can you see that? Instead of explicitly listing those, you can actually go and ask an array object, what are your instance methods, and then iterate and just auto-resolve all those with a little metaprogramming. Your class, the code you actually write is actually quite small. And so that's what we're doing today with FileList. Things to remember from this. Okay, sometimes when you want to be something else, it's better not to inherit, but to use the built-in Ruby toArray in the case of arrays. There's also, if you do something similar for string, there's a toStr method that does something very similar for that. So use those rather than inheritance when you want to mimic built-in classes. Okay, box number 2. Doing nothing. Many people have used Builder. I really don't ask that to get applause. But it makes me feel good, so applause more if you want. Builder was a fun library to write. I wrote it just for the pure joy of writing it. I saw an example, actually in Groovy. There was some code in Groovy that inspired this. And I thought, oh, we could do that in Ruby quite easily. And it turned out to be quite easy. However, in the writing of this, it turned out to be some interesting little corner cases that we had to deal with. And I'm going to talk about those corner cases right now. So if you're not familiar with Builder, it's very simple. Builder is a way of building XML very easily in Ruby. You create a Builder object. You then send messages such as student, such as name, such as phone number to the Builder object, nest them in blocks appropriately, and Builder figures out how to translate all that good stuff into XML using the names of the methods you use as the tags in XML and using your block structure to figure out how to nest it properly. So this is a simple example of using Builder. And the names of the tags and the names of the messages match up through the magic of method missing. I didn't write Builder knowing anything about student names, about student phone numbers. It's just that we trap those methods in Builder with method missing and take the name and create the XML using that. So you can send anything to Builder, and it recognizes it. And it's a really cool, I will claim it's actually easier to write XML with Builder than it is to write XML in XML. And it's great, especially if you're dynamically generating stuff. You can create loops and generate a list of students very easily, pulling stuff out of a database and doing it. Builder is a really handy little library to use. What happens, though, in this example, we have name, phone number, and we added a new call to our Builder class, or to our Builder object, and that's class. So we want to record what class this student is taking. And he's taking an Intro to Ruby, obviously a very astute student in computer science. What happens when we execute this little piece of demo code right here? Yeah, class is a predefined method. Ruby has a method called class that every object has. And class returns the class of the object. There's a number, actually there's quite a number of predefined methods in object. There's class, there's ID, there's toS, toString, the list goes on and on and on. If you use any of these predefined methods in your XML, Builder has a problem with it because it says, oh, this is predefined. It doesn't get into the whole method missing thing at all, and we've got problems. So, class is predefined. The fix for this, wouldn't it be nice? There's that phrase again. Wouldn't it be nice if? How can we inherit from object without actually inheriting from object? We would like to be an object, but not get all the, I'm not going to say garbage, but all the extra stuff that comes with object. We don't want it for our Builder class. So how are we going to handle that? Well, in Builder, we're going to change it so instead of inheriting from object, it's going to inherit from something called blank slate. And it is blank slate that I want to talk about today. Here we go. Blank slate, it turns out, is really easy to write. Well, almost. What happens when we run this? Do you see what I'm doing here? I'm grabbing all the instance methods that are available in the blank slate class. I'm iterating through each of them, and I'm undefining that method. When you undefine the method, that makes it disappear from that class. So blank slate will not have class. It will not have ID. It will not have toS defined in it. So we just iterate through them and remove them. What happens when I run this demo? Well, we get the right XML, but we also get a couple warnings because we were a little overzealous in removing methods. There's a couple methods such as _ID and _send that the system kind of uses, and if you remove them, it may cause serious problems. That's easy to fix. So we'll just undef it unless the name begins with double underscores. And actually, I think in the real version of blank slate, we also avoid removing instance eval, because it turns out instance eval is a interesting method to have around, and probably not too many XML files that have instance eval as a tag name. So that was kind of a safe one to leave in. So still, that's pretty cool. And if we run this, we get exactly the right code. Great! I love that. Simple, direct, easy to run. I love Ruby. Is this good enough? Have we covered all the corner cases? Well, again, blank slate was released pretty much like I've just showed you into the wild, and people began writing in and saying, hey, there's a problem with this XML builder, that these methods are not appearing in my XML, even though they should. Oh! What are we doing here? We require blank slate. So blank slate loads, it removes all the methods from it internally, so now it is a blank slate. And then in our application, we decide, wouldn't it be nice to have a globally available method called name? We put it into kernel. Kernel is the module that gets included into objects. So anything you define in kernel is available on every object, including blank slate. Now, if we could arrange our code so blank slate is always the very last thing ever loaded, so I did this addition to kernel before I loaded blank slate would handle it and remove it when it was loaded. Unfortunately, it's too late at this point. Blank slate is already loaded, it's already removed all its methods, and now I go adding something to kernel, and blank slate picks it up automatically. That is not a good thing. So again, this will result in the wrong number of arguments error for the same reason that class did, because now name is predefined. So we're going to deal with this. Turns out this is also pretty easy to deal with in Ruby. I'm going to refactor blank slate just a little bit. Undef method is a private method, and I want to be able to call it somewhere else. So in preparation for that, we're going to wrap it up in a method called hide. We'll use method hide in that loop that undefines all our methods. And now hide is available globally. And then we're going to add something to kernel. How many people have used method added? You know what method added is? It's a hook into the Ruby code itself. Ruby, when it defines methods in classes and modules, will look for a method, a class method called method added. And if it finds it, it will call it and pass in the name of the method that was just added to that module. So, I want to direct your eyes to the third line in method added. It says blank slate.hide. When we add a method, I want to hide it inside of blank slate if the module it's being added to itself is kernel. So if kernel gets a method added to it, we remove it from blank slate. So blank slate gets kind of late notification of any methods being added. If the module we're adding a method to is not kernel, then that's okay, because I don't care, because it's only kernel that's going to bother a blank slate. So I check to make sure we're only hiding it. If it's kernel, the first and last line of method added is just a good way to use hooked methods, because someone else might have hooked into method added, and you want to make sure that you call their code as well. Otherwise, you will obliterate their use of method added. So that's just good. I think Rails has a way of doing that automatically. It's method chain or something. Alias method chain. So Rails has a little way of doing that very automatically. But that's essentially what we're doing here, is just being courteous in using method hooks. And anytime you use a method hook, please use something similar to this. So, and note at the bottom of the screen says, we need something similar for object. You have to repeat this code in object, because you can add methods directly to object as well as kernel. So a very similar little set of code will go in there as well. Okay. Now, are we good enough? Have we covered all the corner cases? I added that to Builder, released it again, and I thought, we've solved everything. Everything's good and cool. And then all of a sudden, bug reports started coming again. It says, I'm using this method, and it's still not showing up in Builder like it should. It's still not showing up in my XML. So I scratched my head and said, send me your code, because I've got everything covered. I can't see how possibly we could be missing anything. And so they sent me the code, and I looked it over and discovered this. Very similar to the problem before, but subtly different. In this case, we are creating a new module called capital name. Inside the module name, we define a method called name, and then we include the module name into the object class. This is actually a very common way of extending core classes. You put all the extension things in a module that contains the extensions, and then in one place in the core class, just include the whole thing all at once. So this is actually good practice and recommended. Problem is, it totally bypasses the method adding hook, because we're not adding methods now to object. We're including an entire module with lots of methods in it. So fortunately for us, okay, that fails as an example there. Fortunately for us, there's a hook feature called append features. And I'm not actually going to walk through this code because if you saw the method added thing, it's almost exactly identical to that. We have to make sure that whenever we include a module, well, append features is called whenever a module is included. So we can find those events. We check to see that we're in the object class, and then we remove all the methods. Go ahead and hide the methods that are in that module in blank slate. So blank slate can capture that behavior as well. And that has turned out to be pretty good. And that's what we're using currently in Builder. And I don't think I've got any reports from anyone saying they're having problems now. I look carefully over the audience. No one's waving hands. Good, good, good. But if you want to see the exact details, I encourage you to go grab the code for Builder and peruse it. It was a really fun library to write, and I really enjoyed doing that. Okay. This is the example that's not in a real library that I use. But I think the techniques in here are interesting. And I'm really hoping someone will find a good use for it. My example will probably not end up being a good use, and we'll talk about the whys of that. But the technique is fun, and that's good enough for me because I like to talk about fun code. You've seen this, right? This is just Rails code. If you've done any Rails programming at all, you've seen this all the time. User is a Rails active record model, and has a find method on it. And we're saying find all the users whose name is Jim. And you see, and if you look at that, say, that's interesting. We have name equals question mark in quotes. That is actually SQL code. So we're mixing a little bit of SQL code with a little bit of Ruby code, all kind of in one thing. And it's that whole symmetry, clarity, beauty thing is bothering me at this point. Because one thing I know I can do is if I have a list of users, I can call select on it, pass it a block, and in that block I say, okay, does this user's name equal Jim? And that should be a double equals there. And if it equals Jim, then that is true, and select for me all the users whose name is Jim from this list of users. That is all Ruby code, and that's the way we write Ruby code every day of our lives. None of this SQL stuff that we have to match with. So I'm really drawn to the select way of doing things, but I know that the database is there for models, and I have to do that somehow. But wouldn't it, here's this phrase again. Wouldn't it be nice if there was a way we could use select on active record models? That would be so cool. So we could say this, user.select, and give it the block that has all our criteria. We code everything in Ruby, and everything would be beautiful, and we're all happy. We never have to deal with SQL again. So let's write select. And here's my first attempt. I hear some coughs from the audience. Do you detect some problems with this code? A performance issue? Right, exactly. Premature optimization is the hobgoblin of I'm mixing quotes. I'm mixing quotes. Okay, it's hugely inefficient. Look what I'm doing. I'm grabbing all the users from the database, and then I'm putting them in a list. So if I have 1 million users, I just have an array with 1 million entries in it. Then I sort through them for the handful of users whose name is actually Jim. Not really efficient. Not efficient at all. It's slow. Large tables are going to absolutely kill this code. You know, databases are actually, as much as I rail against databases, they are a good thing. They do things very well. They have really efficient algorithms for searching data in the tables, indices set up to track this stuff, and we're not using the database at all for this, just for the sake of being able to write everything in Ruby. So I've got to I've got this problem. I want to do everything in Ruby, but I also want to take advantage of the database as well. So what can we do? Well, I'm going to hypothesize a magic implementation of select. And the magic is, okay, we have this little magic method called translate block to SQL. We pass it the block, and it will come up, and the result of this method will be a condition that we can pass into Rails and let Rails and SQL and the database do all the good work that it likes. It'll translate it to the form at once, and then the database does its job, but we are still writing everything that we do in Ruby. That would be really cool. Except how would we do that? Well, I can think of a handful of ways we might accomplish this. We could actually parse that code. How many people have written a parser? Great. Was it a lot of fun? Actually, yeah, probably it was, but it was also a lot of work. And just to solve the problem of writing code and writing a Ruby, let's ask this, how many people have written a Ruby parser? Max, you can raise your hand. That's a hard thing to do. Ruby is an interesting language to parse. And actually, I think there's some libraries out there that will handle some of that for you. But that's a little too much work for me because I'm looking for the simple solution I can write in an evening. Well, oh yeah, this is what this is a small snippet of code from the Ruby parser built into Ruby itself. So I didn't want to get into there. There's a library called parsetree. Yes! Thank you, Ronnie. Parsetree is a wonderful library. And it bypasses the whole, oh, how do I parse Ruby question by saying, look, there's one piece of code that really, really, really knows how to parse Ruby, and that's Ruby. So let's let Ruby parse it, and we'll go into its guts and rip out the abstract or the parse tree that's built into Ruby itself, and we'll expose it into Ruby code. And it's a really cool idea, and I really recommend doing that. In fact, that's such a good idea that someone else had that idea. And if you look up the Ambition project on Error the blog at this URL, he does exactly that. In fact, he writes a version of select using parsetree to get at the data. So if you want to do this, this is a good way to go. And look at that library, and I think he's just kind of getting started. I'm not sure how far along he is with it. There's some really cool ideas, but we're not going to do it that way. Mainly because someone else is doing it, and that's not the topic of my talk. Why don't we just execute the code? If I execute the code, what's going to happen? Keep that thought in mind for just a second. And this is an IRB session for your illumination. We start IRB, we load a library called Node, well, actually Node 1. And I create an object called table node. So we're going to be dealing with nodes. Table node is I'll tell you in a little bit what a node is. But a table node is a node that remembers a database table. So we tell it to remember the name of users, which is the name of a database table that backs our active record model. We store that in a variable called user. And then we call a method on user. The method is .name. And we store the result of that method in a variable called result. And then we print out the result. We convert result to a string, and we get users.name. Ooh, what just happened? That's really interesting. I created an object. I called a method on it, and the result of calling that method, if I convert the result of calling the method to a string, it tells me what method I called and what object I called it on. And actually, it does something a little bit different than that, actually. It converts that method call on user to a SQL fragment that references the table.field name. Cool. I can now get field references from within Ruby code. just by using this table node. And just to illustrate it further, I also ask for the age field in user, and when I convert the result of that to a string, I get users.age. So I can build up SQL from very simple method calls. And the implementation of table node is trivial. It's two classes. The first one is table node, which we're using directly, and it just remembers the name of the table that we're referencing. And when you convert that to a string, there at the bottom of the screen, you see that it just returns the table name. Trivial code. The only minor tricky stuff in it at all is a method missing call. And when we get a method on our table node, it says, I am going to remember the method that was just called by creating a new object called a method node. The method node will recall me, the table node, plus the method that was just called on me, and I'll return that as a result of the method call itself. And so the method node is the result of calling a method on a Ruby object. Here's method node. Again, really trivial. It just records the object and the method name, and when asked to convert it to a string, does exactly that. That is all the code you need to implement that IRB session. That's kind of cool. We're partway to converting Ruby code to SQL, because we can convert method calls on objects to SQL fragments that reference fields on tables. But we've got to do a little bit more than just convert field references. How do we handle this? How do we say username equals Jim? How do we record that and translate that into SQL? Well, you know what? Double equals is just a method. And I can define double equals on Node. I can see some of you smiling because you're seeing where this is going. And I can create a new kind of node within, you're going to see a lot of different node classes in this implementation, called a binary op node. And the binary op node says, okay, for double equals, the SQL equivalent of that would be a single equal. And I have to remember the left-hand side and the right-hand side of the equals, and I'll record that in the initialize. Well, let's go ahead and show the implementation of binary op mode. We record the operator, the left and right-hand side. And then when we 2S the whole thing, we just convert it to a SQL fragment that has parentheses around it, so we don't have to worry about precedence, and throwing in extra parentheses doesn't hurt. And we have the left-hand side converted to a string, the operator converted to a string, and the right-hand side converted to a string. Wow! Binary op node is pretty easy as well, and not very complicated. So, reiterating, capture the method in the node class, create a node object that represents it, initialize that node object with the things that it needs to know, and just return that. Implementing the node is pretty trivial. And running this now, create our table node. We execute the code user age equals 50. And store that in res1. And when we convert res1 to a string, it says users.age equal 50. It's the SQL where clause for that Ruby code right there. Let's try it again. Let's do the same thing with the string now. Let's say user.name equals Jim, double equal Jim. And when we convert that, the result of that to a string, we get users.name single equal Jim. Ooh, I got a problem. Yeah, we have no quotes around Jim. It's easily fixed. Small matter of programming. What we've done is that we've not distinguished, we're taking Ruby objects and just dumping them out as strings. We really need to differentiate the conversion. We need to capture the conversion of Ruby objects into SQL objects. Numbers just 2S on a number, that's fine. However, string, when we convert a Ruby string to a SQL fragment, we really want to put quotes around it. So we need to, surprise, create a node class for those. So let's create a literal node class, and that just handles simple things like integers that convert directly into SQL. And then we'll create a string node that handles the conversion of strings into SQL strings, and it does that when you call 2S, it just adds single quotes to either side of the string. And probably you want to make that a little bit fancier and handle some escaping in that string as well. Just be aware of that, but we're keeping it simple here. Now, we have a problem. I've got a bunch of different, well, I got two classes, literal and string, that I have to make sure get applied to the right kind of Ruby objects as they come in. So we have to look at a Ruby object, and we have to make a decision, how do I apply that Ruby object and come up with the right kind of node for that Ruby object? Well, you could do this. I could create a method called wrapInNode. It takes an object, just runs through a case statement in that. And this will work fine. I don't like this in particular. The reason is I've got a wonderful OO language, and objects know how they themselves should do things. Why don't I ask, instead of centralizing all this conversion into one place, why don't I distribute it among the objects so every object knows how to convert itself into a SQL node? So what I would rather do is something like this. Open up the object class, create a as a SQL node method, and it just wraps any arbitrary object as a literal node. And then string, which is a special case that I want to handle, I just wrap strings up in a string node and return that as well. They're both called as a SQL node. The key is we're opening up core classes here, so we want to be careful with the names of the method. This is perfectly fine Ruby, but you want to be careful because you're opening up core classes and there could be name collisions with other libraries. So that's why I named it as a SQL node. I felt that name was unique enough that I probably wouldn't collide with any other arbitrary Ruby library adding things to string and adding things to object. So just be aware of that issue. And now, converting any object to a node is really, really easy. You just ask that object, please give me yourself as the proper node. Now we need to tweak node just a little bit. It needs its own as a SQL node method. And since it's already a node, just return itself. That works actually perfectly fine. And then we need to use it. So when we create a binary up node, we need to make sure that the right-hand side of the operation is converted to a node. Now, the left-hand side is a node object already. That's why we're here in this code. So we don't need to convert self. It's already a node, but other may or may not be a node. We just convert it to a node. Now, when we run this, single quotes. That's really cool. We can convert arbitrary Ruby code to SQL just by executing the Ruby code. Okay, what's left to do in this example? Well, there's lots of operators we need to touch yet. Double equal is not the only one. We need to hit all the other greater than, less than, greater than equal to, less than or equal to, all the plus, minus, star, and divide operators, and a bunch of other operators. We might want to consider things like nil question mark. Nil question mark is the Ruby idiom for doing that. Perhaps node should take nil question mark and translate that to is null. Okay, so there's perhaps pattern matching should be converted to the SQL-like operator. Maybe, maybe not, I don't know. But there's all kinds of things that we could add to that. And then if we want to write select, it's pretty much just this. Except I noticed I forgot to do a 2S call on our table, the result of the block. But we take the block, we execute the block, passing in a table node object as the argument. So when we evaluate our condition, the condition gets evaluated against the table node object, builds up the SQL code as we write the query, and when we're done, that result, that con, can be taken, converted to a string, which I forgot to put into the slide, and passed into find all, and we've got our selector, we've got our magic convert block to SQL. Cool. So why don't we do this? What are problems with this method? Well, there's a number of them. Most operators are commutative. So we can say user.name is Jim, or we can say Jim double equals user.name. The first one works. The second one has a small problem, and that double equals is being sent to the string class. String doesn't know about nodes. So it's going to return true or false. It's not going to return the proper node object to capture that. So that is a problem. We can play with that. We could override double equals and capture that, but then we're playing with really fundamental definitions in Ruby, and I'm just a wee bit uncomfortable with that. So that's a small problem. We can either solve it or decide to live with it. Actually, if you have mathematical operators like plus, minus, those actually handle the whole coercion problem by a protocol called coerce. So in Ruby, if you have a fixed num and a floating point num, you have to add them together. You have to figure out what's the proper result for those things. They participate in a little method called coerce that figures out the proper common class to do that. You can actually tie into coerce in Node and make sure that if the node is on the right-hand or left-hand side, it still works and it doesn't matter. So mathematical operators are okay, but some of them, such as double equal, will not quite work right because they don't participate in coerce. Okay, but here's a bigger problem. And I think this is really the killer that really stops this technique from being useful for SQL. And that's the double ampersand and double vertical bar operators are, well, they're not methods. You cannot override them as methods. And the reason is that double and double vertical bar, the and or operators, short circuit their evaluation. If they can determine the truth, true or false, of an expression just by looking at the first operand, they won't ever evaluate the second operand. So it's difficult to define that kind of semantics in a method, and therefore Ruby doesn't give us a way of hooking into those operators as overridable. So you cannot override double and double vertical bar. You could use single ampersand and single vertical bar instead. But then we have to write special Ruby code inside those select blocks rather than regular Ruby code, and that's a little bit uncomfortable for me. A bigger problem also is that the not, the bang operator, and the bang equal operator also are not overridable. So you can never say not condition. It'll always say bang in that expression. It'll return true or false. It will never take that and convert it to a not node. There's just no way of doing that. Likewise for the not equals. Can't change them, can't override. So that's a problem. And so I wouldn't really recommend this technique for SQL. It's a great example to kind of motivate the problem. But I'm kind of throwing this out because I'm really hoping someone will have a great idea for using this. I think it's a beautiful technique. It's a solution looking for a problem, perhaps. Maybe evaluating expressions in graphing or some kind of mathematical analysis this could be useful for. Maybe you have a problem domain where, oh, hey, this would be really useful to use. But the technique is essentially capturing Ruby code execution, tracing what gets called, and building up a structure of that so you can tell what has happened in the past. Actually, we use this in a very small, limited way in FlexMock. FlexMock has the ability to record transactions as they happen on a mock. So later you can play back. You can have a verified good way of doing something and a new way of doing something, and you can verify that they interact with the mock in the same way. In a very limited fashion, we're doing with that, but nothing like this. I got this idea actually from a Smalltalk library, Glorp, which does this in Smalltalk, very similar. There's also a library in Ruby called Criteria that does this as well, but it suffers from the problems that we've mentioned before, but you can look at those. So, advanced Ruby class design. What did we learn? Well, we saw a lot of fun code. That was actually my goal for today. But I think we really showed now that language shapes the way you think, and when you're in Ruby, you need to look for Rubified solutions to your problem. And in doing so, you really kind of have to understand the corners of your language. You can come into Ruby from Java, from C++, or from a different language and use Ruby very quickly But until you kind of learn those corner cases, learn what hook methods are, learn about metaprogramming, learn about redefining operators, you're going to miss a lot of good solutions to your problems until you kind of get that core language under your belt. So I really encourage you to go and research the language and understand those kind of corners. Also, I want to encourage you to kind of go ahead and think outside the box. Look for those unusual solutions. You don't need them all the time. In fact, you don't need them most of the time. If most of your code looks like this, I would be very, very worried. But there are occasions when you need a special solution, and Ruby can step in and find that special solution for you. So go ahead and think outside the box, because after all, about 3 years ago, someone had not stepped out of the box with regard to web frameworks. I'd still be writing this kind of code. So thank you very much.